This video is all about developing a unit circle and helping you understand how we use a unit circle in evaluating trigonometric ratios. So first of all, we're talking about a unit circle. And a unit circle has a radius of 1. And I have lots of points on here giving me some guide of how to draw in my unit circle here. And here's my pretty unit circle. So obviously, if we had a rotating ray starting in standard position, we could rotate this ray all the way around the circle, and one full rotation is, of course, equal to 2 pi radians. 2 pi radians being equivalent to 360 degrees. That's one full rotation. Now, if we start thinking about fractions of this rotation, this is going to help us develop this unit circle. Just some other quick reminders here. Our unit circle is on the coordinate plane, and the coordinate plane does have the 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. What we're going to do is take a more detailed look at quadrant 1, because quadrant 1 kind of gives us everything we need to know to fill out the rest of the circle. Just one more quick reminder. Our circle has a radius of 1. This is critical to think about. So one more time, that's why it's called the unit circle. So diving into quadrant 1. So here's quadrant 1, and right in quadrant 1 I have drawn a pi over 4 rotation. Of course, pi over 4 is equivalent to 45 degrees. If we went all the way to the top, that of course would be pi over 2, which is 90 degrees. So we're just halfway there. And of course here is 0 radians, which is the same as 0 degrees. Just to keep in mind that everything in quadrant 1 is, of course, positive. The x values are positive, the y values are positive. Now what I want you to think about is what we've talked about in class regarding 45, 45, 90 triangles and 30, 60, 90 triangles. If we have a 45-degree rotation here, and I drop the altitude down to the x-axis. Remember, altitudes are always drawn relative to the x-axis because they are measuring a vertical distance. So if we're on the unit circle and we're given that we have a radius of 1, what does that mean for the horizontal change and the vertical change? So think about it. This is going to be our x coordinate, and this is going to be our y coordinate, which is going to lead us to the location of this point, which is what we're going to need as a point on our unit circle. So if our radius is 1, that means our hypotenuse is 1. And if our hypotenuse is 1, then the legs are 1 divided by root 2. And 1 divided by root 2 is reduced and rationalized to root 2 over 2. So we're going over root 2 over 2, and we're also going up root 2 over 2. So the coordinates of the point on the unit circle that are 45 degrees up are root 2 over 2, root 2 over 2. So visualize our unit circle here. Here's just this part of it right here in quadrant 1. We're just focusing on quadrant 1 right now. So 45 degrees, pi over 4 radians. What's its coordinate on the unit circle? Root 2 over 2, root 2 over 2. This is x, this is y. Staying in quadrant 1, let's look at the 30 and the 60. So if we go up 30 degrees is the same as pi over 6. We still are just talking about a radius of our circle that's equal to 1. So visualize the circle here. And the next thing I want us to do is, just like we've done in class, I want to drop an altitude down and create a right triangle. Because we really don't have trigonometry or trigonometric ratios until we think in terms of a right triangle. So here is my 30-degree angle right here, which makes this 60. And of course, our radius is 1. Remember our ratios for our 30, 60, 90 triangle. So this time though, our hypotenuse, which is opposite our right angle, is 1, which makes my opposite side half, because the hypotenuse is twice as big as the short side, which then makes my long leg root 3 over 2. And I'm just looking at this particular triangle. Maybe I'll have to draw another one for our 60. So we're just looking at this triangle where our reference angle here is 30. So what are our coordinates when we rotate up 30 degrees, which is pi over 6 radians? We are out root 3 over 2, and we are up 1/2. So this is what we get if we rotate only 30 degrees. Now, the pink line is showing us a rotation up 60 degrees. So if we were to drop a line down, an altitude, we have a totally different triangle. So let me quickly resketch that, and let's just look at the 60. So here's the 60, pi over 3. Dropping that altitude down. Now, do think, it's the same exact triangle, they're just oriented slightly different. So this time we still have a radius of 1 on our unit circle. So our hypotenuse is 1, our short side is 1/2, our long leg is root 3 over 2, which means the coordinates of the point on the unit circle in the 60-degree rotation are just the opposite for the 30-degree rotation. X is 1/2 and Y is root 3 over 2. So we can see that more clearly here, over 1/2 and then up root 3 over 2. So this is for a 60-degree rotation and this is for a 30-degree rotation. We need to know those. So we've seen the 45, we've seen the 30, and we've seen the 60. Now we can do these 2 points as well very quickly and easily here, remembering that our radius of our circle is 1. The radius of our circle is 1. That would make the points here at 0 degrees, 0 radians, be over 1 up 0. And then the point on the unit circle at pi over 2 in the rotation would simply be over 0 up 1. So we're going to start taking this information, and our goal for this video is to be able to fill in this entire unit circle. Remember, it's a unit circle. So our radius is equal to 1. So let's fill in the first quadrant that we just did on the 2 previous slides. So first of all, let's fill in just the degrees. This is 0 degrees, this is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So that takes us through our whole first quadrant. Let's fill in the radian measurements in quadrant 1. This is 0 radians. This is pi over 6 radians, pi over 4 radians, pi over 3 radians, and pi over 2 radians. Now, let's fill in the coordinates. We clearly know that our radius of our circle, which I'll highlight for us again right here and right here, they're all equal to 1 because this is a unit circle. So that means our coordinates over here at 0 degrees are out 1, up 0. And of course, at 90 degrees over 0, up 1. Now, I'll show you once again our 45, the coordinates of our 45, and we found that just by using the ratio of the sides in a 45, 45, 90 triangle. At 45, it's root 2 over 2, root 2 over 2. And then let's be reminded of our 30 and our 60. Our 30 is root 3 over 2 and 1/2. Our 60-degree rotation is out 1/2, up root 3 over 2. Now, this, of course, is quadrant 1. And nothing is going to change as we move through quadrant 2, 3, and 4 except for the signs. Because when we move to the left of the y-axis, all of our x-coordinates simply become negative. But before we do that, let's fill in the rest of the degrees. 30, 45, 60, 90, 120, 135, 150, 180. Let's keep going into the bottom quadrants. So 180 plus 30 is 210, 225, 240, 270, 300, 315, 330, and then finally 360. 360 degrees being one full rotation, one full revolution. Let's keep going with our radians. We learned how to count these by just counting the fractions. So 1/6, 2/6, 3/6, 4/6. 4 over 6, of course, is the same as 2/3. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, which of course is the same as 4 pi over 3. To the bottom, this is 9 pi over 6, which is of course the same as 3 pi over 2. So 7/6, 8/6, 9/6, 10 over 6. 10 over 6 reduces to 5/3. And then 11 pi over 6. So those are all the radian. Ooh, missed one. We got to do the 45s. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, and yes, 7/4. Now we've got all the radian measurements in. Now let's finish filling in those coordinates. So think about what's happening here. If we mirror over these coordinates, only the x's are going to become negative. So we're going to have negative 1/2 root 3 over 2. We saw this on the triangles that we discussed in class. Negative root 2 over 2, positive root 2 over 2. Negative root 3 over 2, positive 1/2. And then, of course, at 180, we are back 1, up 0. Next, to the bottom. Now, let's reflect over that x-axis, and we're flipping down. These two angles, these two rotations, have the same reference angle of 30, but now in quadrant 3, everything is negative because we're going back and down. So back root 3 over 2, down 1/2. Back root 2 over 2, down root 2 over 2. Back 1/2, down root 3 over 2. And then finally into quadrant 4, everything on the right-hand side of the y-axis has a positive x coordinate. So if we're filling in our coordinates here, and let's start down here at 270. This, of course, is 0, negative 1. So now we're just going to be mirroring the 60 and the 5 pi over 3. 5 pi over 3 is, of course, 300. So they are vertical reflections of each other. So positive 1/2, negative root 3 over 2, positive root 2 over 2, and then negative root 2 over 2, positive root 3 over 2, and negative 1/2. So that is all of our coordinates filled in, and I just noticed that I did not put my 2 pi radians up by 360. That is the full unit circle completely filled in.